Hello friends, this video on solutions part 9 is brought to you by examfear.com. No more fear from exam. The question is concentrated nitric acid used in lab is 68% nitric acid by mass in aqueous solution. That means I have a solution, I have nitric acid here. This nitric acid is my solute and my water is my solvent because it is aqueous. Correct. 68% nitric acid by mass. So first, the moment it comes, we can say that let total mass of solution be 100 gram. So in this case, nitric acid will be what? 68%, that is 68 gram. In the water will be remaining, that is 100 minus 68, that is 32 gram. The moment you come see this 68% nitric acid by mass, you can conclude these two things. Correct? Total mass of solution is 100 gram, out of which 68 gram is nitric acid, that is my solute, 32 gram is water, that is my solvent. So please note here, water is less, nitric acid is more, but still I am saying water is my solvent because water is a universal solvent actually. Correct? Now we have to, the question is what is the molarity of the acid? So molarity is what? Capital M is nothing but moles of solute, in this case nitric acid, by volume of solution. Correct? So moles of nitric acid I can easily find because the mass of nitric acid is there. I can find the molar mass, I can find the moles. Volume of solution is something I have to find. I have density is given, density of solution is given, I can easily find volume of solution. Let me find these values then. So let's find moles of nitric acid. Nothing but mass of nitric acid by molar mass of nitric acid. What is the mass of nitric acid? 68 gram. Correct? What is the molar mass? Molar mass we can find very easily. Let's find here only HNO3. Hydrogen is 1, nitrogen is 14, oxygen is 16, and there are 3 oxygen molecules. So you saw this 48, 49, 14, it is 63 grams per mole. Grams per mole. You solve this, gram gets cancelled. You get 68 by 63 grams per mole, or 68 by 63 moles. I'll not solve it now. It will be like this. That is my moles of nitric acid. The next is volume. Volume of solution I have to find. Density is equal to mass by volume. So volume of solution is nothing but mass of solution by density of solution. Please use these terms here, else you will get confused. If you just say volume, then the moment you write mass, you will get confused. I have to take the mass of solute, solvent, or solution. So better to say volume of solution is nothing but mass of solution by density of solution. What is the mass of solution? 100 gram. And please write units also. Density of solution 1.504 gram per milliliter. This gets cancelled. You solve this, you get 66.5. What will be the unit? Milliliter. But you want what? Volume of solution in liter. This become 66.5 divided by 1000 liter. This is nothing but 0.0665. So I have all the values. Let me put these values here. M is nothing but moles of nitric acid, that is 68 by 63 moles, and volume is nothing but 0.0665 liter. Correct? You solve this, you get 16.23 moles per liter, and that is nothing but 16.23 capital. Easy only. The question says solution of glucose and water is labeled 10% W by W. So this red is my glucose and that is my solute, and blue is my water and that is my solvent. 10% weight by weight. The moment it says 10% weight by weight, you have to assume let total mass of solution is 100 gram. So the mass of glucose solid will be what? 10% of 100 gram, that is 10 gram, and the mass of solvent will be what? 100 minus 10, that is 90 gram. That is the first thing that should come to your mind. Now we have to find the molality, mole fraction, and mole fraction. And also if the density is given, you have to find the molality. So we'll do that later. First find the molality and mole fraction. Correct? So molality is what? Moles of solute divided by mass of solvent. Please understand, in molality it's a solvent in kg. So what is the moles of solute? Solute is glucose. Mass is given, I can easily find molar mass, I can find the moles of solute. Correct? And mass of solvent in kg also I can easily find because the mass of solvent in gram is given. So let's first find the moles of solutes. So here my solute is glucose and solvent is water. So let's find this moles of solute. Moles of solute, that is glucose, is nothing but mass of glucose by molar mass of glucose. Mass of glucose generally in gram, that is 10 gram. Molar mass of glucose is what? So let's find somewhere here. C6H12O6. 6 carbon, 6 into 12. 12 hydrogen, 1 into 12. Sorry, 1 into 12, yeah. And then oxygen 6. 6 oxygen into each oxygen has a molar mass of 16. You solve this, you get 180 gram per mole. This is 180 gram per mole. So this will be my number of moles. I'll not solve this. This will come 10 by 180 moles. This is I have now. So let's put the values directly only. 10 by 180 divide by mass of solvent in kg. This is 90 grams. That is mass of water is 90 grams. And divide by 1000. Make it in kg. Correct? This one if you solve, you get 16.7 moles per kg. And that is nothing but 16.7 small. And that is my molality. 16.7 ml. Pretty easy. The next is mole fraction. So I have to find, let's suppose, mole fraction of glucose. That is nothing but moles of glucose by moles of glucose plus moles of water. Correct? So what is the moles of glucose? We have seen 10 by 180. That is 10 by 180 divided by moles of glucose again is 10 by 180 plus moles of water is what? Mass by molar mass. Mass of water is 90 gram Molar mass of water is, we have just seen 18 grams per mole, right? So this will be in the mole. This all will also be in the unit of mole. You solve this, mole will cancel and you get almost 0.01. That is the mole fraction of glucose. I have to find the mole fraction of each component actually, right? So if I want to find the mole fraction of water, so I have to find the mole fraction of water, that becomes 1 minus mole fraction of glucose, that is 1 minus 0.01, that is, you can say that 9.99. Correct? That is done. Now we have to find the molarity of the solution. So let's now find the molarity. Molarity of solution or the solid is nothing but moles of solute divided by volume of solution. Please note it's the volume of solution here. Moles of solute, that is glucose, we already know here, right? Let's find the volume of solution. Volume of solution. So we know that density is mass by volume. So volume is nothing but mass by density. So volume of solution will be nothing but mass of solution by density of solution. What is the mass of solution? 100 gram. What is the density of solution? 1 point density of solution. Please note, density of solution is 1.2 gram per milliliter. This gets cancelled. And what you get is 83.33 milliliter, but I want volume solution in liters, so I'll convert this, divide by 1000, 83.33 divided by 1000 liters, then there is nothing but 0.0833 liters. So we'll put these values here now, that's all, right? So moles of solute, 10 by 180 moles, divided by volume of solution, that is 0.0833 liters. You solve this, you get 0.67 moles per liter, and that is nothing but molarity, 0.67 capital M. Right. Let's see this question, little tricky question. How many milliliter of 0.1 mHCl are required to react completely with 1 gram of Na2CO3 and NaSO3 containing equimolar amounts of both? So first, to understand this question, the question says that this HCl will react with Na2CO3 and NaSO3 and have to find how many milliliter of HCl is required. So since it is in moles, molarity, moles per liter, right? So it's trying to ask me the number of moles of HCl required, right? Because this reaction happens based on the moles, but it's just given that we have a mixture of Na2CO3 and NaSO3. For example, it is given that I have Na2CO3 and NaSO3. Total weight is 1 gram. So this is X, this is 1 minus X gram. But it has not told me what is the value of X, but has given me one more clue, it's equimolar. That means the moles of Na2CO3 is equal to moles of NaHCO3. Correct? So for that I have to find the molecular mass of both, because this is nothing but mass by molecular mass. So let's find the molecular mass of these compound. So molecular mass of Na2CO3 I am finding first. Sodium is 23 into 2 because Na2. Carbon is 12. Oxygen is 16. There are 3 oxygen. Solid 106 gram per mole. Similarly, if you want to find the molecular mass of NaSCO3, what you will get? Sodium is 23, only 1. Hydrogen is 1. Carbon is 1, 12. Oxygen is 3, 16 into 3. Solid 84 grams per mole. So let's put this value in this equation. Moles of Na2CO3 is what? Mass of Na2CO3 by molecular mass of Na2CO3. This is mass of NaSCO3 divided by molecular mass of NaHCO3. Solve this. Mass of Na2CO3 we have assumed X. Molecular mass of Na2CO3 is 106 gram per mole. This is X gram is equal to mass of NaSCO3 is 1 minus X gram, and this is molecular mass is 84 gram per mole. Gram cancel, gram cancel, per mole cancel. You solve this, you get X as 0.558 gram. That means Na2CO3 is 0.558 grams, and 1 minus X you will get 0.442 gram. So we'll note these values now. Correct? So that is the information we have. Na2CO3 is 0.558 gram and NaSCO3 is 0.448 gram. Now let's see the reaction that is involved. See, Na2CO3 will react with HCl to form NaCl and H2CO3. Balance the reaction. This is the balanced reaction. And NaSCO3 will also react with HCl to form NaCl and H2CO3. So if you assume that if you take 1 mole of Na2CO3, I need 3 moles of HCl. Anyway, they are equimolar, right? So number of moles of NaSCO3 and Na2CO3 same, equal, given. This is equal to this number of moles. So that should be okay, right? So for 1 mole of Na2CO3, how many moles are required? 2 moles of HCl is required, right? And for 1 mole of NaSCO3, 1 mole of HCl is required. So for 1 mole of Na2CO3, I can say that there are total 3 mole of HCl required. Because we know that this mole and this mole is same, given. Correct? So you have 1 mole of Na2CO3 and I have, or let me say, 1 mole of Na2CO3, 2 moles of this is required. And for 1 mole of, not to confuse you guys more, I need 1 mole of HCl. So total I need 3 mole of HCl for 1 mole of Na2CO3 and for 1 mole of NaSCO3. Correct? So the number of moles, first let me find. Number of moles of Na2CO3 is how much? Mass of Na2CO3, that is 0.558 gram by molar mass we just found 106 gram per mole. That is nothing but we have 0.00526 moles of Na2CO3. Similarly, we have the same moles of NaSCO3 because it's equimolar. Correct. So now logically, if you see, if I have 1 mole of Na2CO3 and or I have 0.00526 mole of this, I mean I have 1 mole of Na2CO3 and 1 mole of NaSCO3, I need 3 moles of HCl. So if I have this mole of Na2CO3 and this mole of NaSCO3, I need 3 into this many moles of HCl. Correct? Number of HCl moles required is what? 3 into this value. Correct? This many moles. That is nothing but 0.01578. Hope you understand what I'm saying. 1 mole of Na2CO3 and 1 mole of NaSCO3 total required 3 mole of HCl. So 0.00526 mole of Na2CO3 and the same number of mole of NaSCO3 we have actually equimolar. So this many moles of Na2CO3 and this many moles of NaSCO3 will require 3 into this many moles of HCl. So moles of HCl required I have. Correct? I have to find the milliliter. So if you see, the molarity of HCl is given. Molarity is what? Of HCl is nothing but moles of HCl divided by volume of what? Total solution in liter. So I have this given, I have to find this. Let's put the value. Moles of HCl is how much? 0.01, 0.1 m. Sorry, molarity of HCl is 0.1 m given. Moles of HCl is given 0.01578 moles, and this is vol required in liters. So if you solve this here, or vol in liter is nothing but 0.01578 by 0.1 m. That is nothing but 0.1578 liter. Want to convert this in milliliter, this becomes 157.8 milliliter, and that is my answer. So here the trick was the weight of Na2CO3 or NaSCO3 was not given. You have to first find that, given that they are equimolar, and then we should know the reaction. Based on the reaction we can tell, okay, 1 mole of Na2CO3 and 1 mole of NaSCO3 will totally require 3 mole of HCl. So 1 mole of 0.0526 mole of Na2CO3 and 0.0526 mole of NaSCO3 will totally require 3 into 0.00526 mole of HCl. So I know the moles of HCl required. I know the molarity of HCl. I can easily find the volume of the whole solution actually. Thank you. Visit examfear.com to watch more videos, attempt free online tests, get free study materials, find tutors and mentors, and much more. Thanks once again.